Welcome. This video is going to provide some support for Khan Academy. Specifically, we're going to be taking a look at the first Khan Academy assignment in equation solving this week. It's the one called two-step equations. So if you haven't started this yet and want some support or some help before you get started, or if you've done it once and you struggled a bit like me with this 43%, we're going to take a look at a few of them and work through them together. This assignment has 7 questions for you. Two-step equations are kind of short, so they gave you a few extra questions than normal. We're going to go through about 4 examples here together. I'm going to go ahead and make my whiteboard larger now as we look at the first question. We'll zoom in actually first. The first question says solve for n, or solve the equation for n. And we see the equation is 24 is equal to 3 multiplied with whatever n minus 5 is. Shrink the camera a bit. I'm going to make the whiteboard that has that equation larger for us here. So there we see that equation copied. It says 24 needs to be equal in value to 3 multiplied with n minus 5. Another way to think about this equation is saying whatever 3 times n minus 5 is, that has to give us 24. So our goal when we're asked to solve the equation is what number could we plug in for m so that 3 multiplied with this equals 24. One method for solving, whenever you see the n or the variable you're solving for in factored form, if it's stuck inside parentheses, one method, not the only way to solve this, is to distribute or multiply that 3 out. This factored form says 3 was pulled as a factor out of the n and the negative 5, so you can multiply that 3 or distribute that 3 back into both of these terms. 3 times n would just give us 3n, and the 3 also needs to be distributed back to or multiplied with the negative 5. So 3 multiplied with the negative 5 would produce negative 15. So by distributing the 3 or multiplying out, I eliminated the parentheses, and now that makes it possible for me to be able to get the n all by itself, and the n is currently on the right side of the equation. So if I want this equation to have n isolated all by itself, the first layer I want to peel, as Mr. Neville would say, or the first term I want to move, is the negative 15. How do I cancel out a negative 15? I need to add 15. That's the inverse operation, or the opposite, that peels that negative 15 out of the right side of the equation. I add 15 to the left side as well. 24 plus 15 would give us 39. The negative 15 cancels out with the positive 15, so we have 39 is equal to 3n. Now remember, my goal here is to get the n isolated all by itself. I'm close. Now I have just 3n on the right side of the equation. I want to cancel out this coefficient. The way I peel the 3, or the way I eliminate the coefficient, is to use division. Division is the opposite of multiplication. So if I were to divide by 3, that would cancel out the multiply by 3, the coefficient. It would give me just n on the right side. Whatever I do to the right side of the equation to change its value, I need to do the same operation on the left side to keep everything balanced. 39 divided by 3 gives us 13. So I believe my answer is going to be 13 here. So I'm going to go ahead and shrink that whiteboard again. I think my answer is going to be 13. So we'll plug in a 13 for n. Before I actually hit check, I'm going to check my answer myself. I'm going to take this 13 and I'm going to place it into the equation. 13 minus 5 would produce, or make 8. 13 minus 5 is 8, and 8 times 3 would make 24, which makes me a lot more confident that when I hit check, we're going to hear that noise that says you were correct. We're going to move on to the second question now. So here we see for our second question, give me a second to fix the whiteboard. This new equation says negative 30 has to be equal to 5 multiplied with x plus 1. So again, negative 30 needs to be equal to 5 multiplied with whatever x plus 1 makes. Again, there's multiple ways to go about solving this equation. I'll show you one method that works for me. I'm going to distribute, because whenever I have factored form, I usually just want to get rid of those parentheses so I can start getting the x all by itself, and one way to get rid of those parentheses is to distribute. So I'm going to take the 5 and multiply it with x, and I'm going to also multiply it with positive 1 to eliminate those parentheses by using distribution. 5 times x gives us 5x. 5 times positive 1 gives us positive 5. For the remainder, I always bring the equal sign down. Part of the reason I draw this river, I just keep the equal sign on the river the entire time, and that helps me focus on what's in the right expression, the right side of the equation, versus what's over on the left side of the equation. Here I see the x is located in the right expression again, so I want to get that x all by itself. The first layer I want to peel, or the first term I want to move, is the positive 5. How do I cancel out positive 5? The inverse operation there is going to be to subtract 5. By subtracting 5, I eliminate the positive 5. Any change I make to the right side of the equation, I need to do the same thing to the left side of the equation, or the equation would break. It wouldn't be true anymore. Bring the 5x down, and I need to figure out what is negative 30 minus 5 going to make. Hopefully we recall there's a bunch of ways to combine two negative numbers. For me, I recall whenever I combine two negative numbers, I just add them up. 30 and 5 would make 35. So if I have two negative numbers combined, I'm going to have a negative 35 after I add those two negative numbers up. That negative 35 needs to be equal to 5 multiplied with x. I could divide both sides of the equation by 5, because that would cancel out the multiply by 5. Or, at that point, some of you may just solve by inspection. Some of you may have already known that x was going to have to be negative 7, because negative 7 times 5 is what produces negative 35. So that's how I arrived at negative 7 for this second answer here. We'll go ahead and see if that's correct, and then we'll show one or two more examples. So checking my negative 7. Looks like we got that correct. We're going to move on to the next one. Okay, the next one we see is actually a little bit more straightforward. I would encourage you to actually pause this video right now and try to work through this, because this should be something you can handle on your own. After you work through this equation, I'm going to quickly run through on my whiteboard how to do it. Alright, welcome back. Hopefully you had some success solving this example on your own. If you didn't, here's how I would have solved this equation. 7n minus 4 equals 31. I see the n is on the left side of the equation. I want to get that n all by itself ultimately. That's how I'm going to try to solve this equation, is get that n all by itself on the left side. The first thing I need to get rid of from the left side of the equation is the negative 4. If I were to add 4, let me make this whiteboard a bit larger. If I were to go ahead and add 4, that would cancel out the negative 4. And that helps me get to 35 on the right side of the equation when I add 4 over there. It needs to be equal to whatever 7 times n is. What number times 7 makes 35? We just saw that actually recently with the negative 35 example. I know 5 times 7 is what makes 35. If I didn't know that, I could divide by 7, because that's the opposite of multiplying by 7. And 35 divided by 7 would give me that same answer. It would give me 5. So I'm going to plug in a 5 for that answer. We're going to keep moving, and we will take a look hopefully at one more example. Alright, we're going to skip this answer. Actually, I'm going to put in a random answer. It may be wrong or right. We're going to skip that for now. We're going to skip this one too, because I want to find one. Oh, random guess, and it worked out. Not a single one. Okay, here's the last example I wanted to show you. So sometimes, let me erase the whiteboard, and let me make this into the right spot again. Our equation here says k divided by 4. We see the variable, the k, is inside a fraction, or part of a fraction. That just means k divided by 4 plus 3 needs to be equal to 14. So again, no matter how complicated or different the equations get, when we're asked to solve these equations, one method that always works is to isolate the variable, to use inverse operations to cancel out everything except for the k on the left side of this equation. The first layer I'd want to peel, or the first thing I want to get rid of, is that positive 3. And the way I get rid of a positive 3 is to subtract 3, because 3 minus 3 would make nothing. They'd cancel each other out. If I subtract 3 from the left side of the equation, I need to do the same subtract 3 on the right side of the equation to keep everything balanced. 14 minus 3 would give us 11. So this equation now says k over 4, a fraction, but that really just means k divided by 4, is equal to 11. And again, if we're thinking about inverse operations, the opposite of dividing by 4, what's the opposite of division? It's multiplication. So I'm going to use a multiply by 4, because if I were to multiply the left side of this equation by 4, that would cancel out the divided by 4. The only thing on the left side of the equation would now be the k. But if I multiply the left side of the equation by 4, I need to multiply the entire right side of the equation by 4. So that 11 has also got to get multiplied by 4. 11 times 4 would give us 44. Now go ahead, you should be plugging that 44 back into the equation to check if we're correct. 44 divided by 4 would give us 11. 11 plus 3 would make 14. And that's one way I can check to confirm we're definitely correct when we put in 44 for k. So I hope these examples were helpful. Again, I would encourage you, if you miss any on your own, to continue to use the Get Help feature on Khan Academy or take a look at some of Sal's videos. You can also always feel free to send me an email, and I'm happy to jump on Zoom or Google Hangouts and help you work through a couple examples in live time. Thanks for watching.